Hi everyone, and welcome to the second part of this e-learning, finding unknowns in right-angled triangles. So for this particular portion, you'll be learning how to find an unknown length in a right-angled triangle given an angle and a side, of course using the trigonometric ratios that you have learned earlier. Alright, so how could we use your calculators to evaluate trigo ratios? The calculator that I'm using here is the Casio FX95SG Plus. For most of you who are using this model, I think majority of you are using this model, so it shouldn't be too hard to find your sine, cosine, and tangent keys. We are actually here. Okay, one more thing to take note of, please make sure before you key in your trigo ratios that this letter over here is a D. Okay, it is a D. Okay, this D just means degree mode, and if your calculator is not in the mode, you can go ahead and reset it. Okay, so please take note, especially when you're working with trigo ratios for accuracy purposes in values, when you are using your final answer somewhere that involve a trigo ratio. Okay, please make sure that when you substitute it in another part, you use the 5SF value. Same for Pythagoras theorem. And your final answer, of course, has to be left in 3SF. For angles, instead of SF, we actually count by decimal places. So in the midst of working, use raw value or 3 decimal places. For the final answer, always leave in 1 decimal place. Okay, so how do we use our calculators to evaluate such trigo ratios? Using, for instance, sine 32, all you have to do is just key in sine 32. That's all. And you will get a 5SF value 0.52991. But of course, you don't have to write anything like 5SF here, just leave it as it is, then you change to 3SF. Okay, same thing for this particular question. How do you calculate it? You just simply press 3 sine 48 plus 2 cosine 39 degrees. You will get 37.837. Okay, 5SF first, then you change to 3SF. Okay, always give the intermediate, then you give the final. Similarly, okay, go and key this into the calculator. You will get 15.118. Okay, which is equals to 15.13 SF. Okay, so it's not hard to use your calculator to actually calculate and evaluate trigo ratios. Alright, so now let's take a look at what happens if now I'm given the value of the trigonometric ratio, but I'm asked to find the angle. Now I need to work backwards to find the angle. So how? Alright, so for this particular kind of examples, don't fret, okay? There's this thing called the sine inverse function that helps me find the angle. Okay, I apply the sine inverse, key this to the calculator. How do you key this into your calculator? You press shift and then the sine key. And you will get 51.260 degrees, which I can change to 1 decimal place, 51.3 degrees. Take note that the degree sign has to be written all the way. So that's how you conclude x equals to 51.3. Now take note that x has no units. It is actually a value. Okay, in this case, it is a value. Okay, I believe that you should be able to do the same for 5b. For 5b, you should be able to get that x is 69.5 to 1 decimal place, and for 5c, x equals to 50.9 to 1 decimal place. Okay, explore using the cosine inverse and tangent inverse button. Alright, so in the next few examples, we will actually learn how to apply what we have learned here to use our calculators to evaluate the unknown lengths in a triangle given an angle and a side. So stay tuned for that.